Hello everyone. Today we're going to be talking about the classification of matter. As you know, matter is anything that has mass and occupies space. This flowchart that I have here for you shows that matter can either be divided into a pure substance or a mixture. Notice that there are two types of pure substances. You're either an element or a compound. And there's two types of mixtures. Either you're a homogeneous or heterogeneous mixture. What we're going to do is we're going to define each of these categories in the following slides. So let's take a look at a pure substance first. If you're a pure substance, that means that you have a definite or fixed composition. As I mentioned, elements and compounds are considered pure substances. Let's take a look at the difference between an element and a compound. An element is a substance that cannot be broken down into a simpler substance by a chemical change. The example I have here is hydrogen. When you look at the periodic table, it lists all the elements. Elements, by definition, cannot be broken down. Now, one thing about elements is that the symbol has a capital letter. If an element has more than one letter, for instance, let's say calcium, you'll notice that the first letter is going to be capitalized and the second one would be lowercase. And then, of course, recognize that some elements have Latin derivatives. For example, iron comes from Latin. The symbol is Fe. And in Latin, it comes from the word ferrum. So some of these symbols you'll notice come from Latin. But again, the first letter is capitalized, the second one lowercase. Now, if you are to combine two or more elements in a fixed proportion, you create a compound. That is why a compound is considered a pure substance, because it has a definite or fixed composition. There is only one way to make water, and that is to combine two hydrogens with one oxygen. If I were to change that ratio, for instance, let's say that I had two hydrogens combined with two oxygens, you are no longer making water. You are now making another unique compound. And in this example, it is called hydrogen peroxide. So compounds do have a fixed composition. And the difference between a compound and an element is that a compound can be broken down further, while an element cannot. Now, let's take a look at the other bracket. If you were to put two substances together physically, okay, which would be a blend of two or more pure substances, as long as they don't combine chemically, they're just physically together, you form a mixture. The two types of mixtures that you can form are either called homogeneous mixtures or heterogeneous mixtures. Here's the difference. When the two substances mix evenly throughout or uniformly, that is what we call a homogeneous mixture. Some examples include dissolving sugar in water or salt in water. When you put sugar or salt in the water, the sugar spreads evenly throughout the mixture. In fact, you might hear the word solutions. All solutions are considered homogeneous mixtures. Solutions have two components. The substance that gets dissolved is called the solute. In my example, sugar is the one getting dissolved, so that would be considered the solute. The solvent is the substance that does the dissolving. In my example, that would be water. So solutions are mixtures where the solute and the solvent mix evenly throughout. Now, some solutions could be gases or solid solutions. Let me give you an example. The air that we breathe, or our air here on Earth, is a mixture of various gases, but they're mixed uniformly throughout. Air is considered homogeneous. If you're inside your house, you're breathing about 21% oxygen. If you go outside, you're still breathing 21% oxygen. In fact, the most common component of our air is nitrogen, which makes up about 78% of our air. In fact, nitrogen, being the most abundant gas in our air, would be considered the solvent whereas all the other gases, including oxygen, would be a solute. Other homogeneous mixtures could be, for example, alloys. Alloys are mixtures of two solids that get together. Usually the two solids are two metals. One very popular alloy which is made up of a metal and a non-metal would be steel. Steel is actually made of, the metal is iron and the non-metal is carbon. So that's a very popular alloy. Now, when these metals get together, they get together and they mix with each other uniformly or evenly. And that's why they're considered homogeneous mixtures. Alloys are used to make coins. For instance, a penny is made up of copper and zinc alloyed together. And you have most jewelry is actually an alloy of several metals. You will never have something made up of pure gold. Gold will always be alloyed with something else like copper, silver, or tin. The more gold something has, the more valuable. We use the word carat to express the quantity of gold. So the higher the carat, the more gold it has. But it can't be pure gold because gold is very soft and the piece of jewelry would deform if it was pure gold. Now, a heterogeneous mixture would be when you mix two substances randomly. They are not uniformly mixed. I have some examples I want to share with you. Oil and water, in fact, they don't mix at all. They form two layers. The oil is found at the top and the water is found at the bottom because oil is less dense than water. Granite is a mineral rock made up of several minerals that are randomly dispersed throughout. Another example would be a chocolate chip cookie. If you analyze a chocolate chip cookie, the chips aren't distributed evenly. You might have a cookie that has more chips on one side than on the other. So as long as it's not uniformly mixed, it would fall under heterogeneous mixture. One of my favorite examples would be trail mix. Trail mix is an example of, various substances, perhaps peanuts, raisins, cashews, almonds, M&Ms, and they're all randomly mixed throughout in the container. Other examples could be like spaghetti and meatballs or alphabet soup. Sand and water is a pretty good one too. The sand's at the bottom, the water's at the top. A salad would be another example of a heterogeneous mixture, or a bag of coins. All of those are mixtures in which the substances are mixed unevenly throughout. So here you could see our classification scheme. So what makes a pure substance by definition would be that it has a definite or fixed composition. Here you see elements. Remember, they are substances that cannot be broken down further, whereas compounds can be broken down into their individual elements. For instance, salt, which is NaCl, sodium and chlorine, that would be a compound. And if you get salt and you break it down chemically, it would break down into sodium and chlorine, and then those two substances would now be considered elements. Whereas a mixture is when you blend two or more pure substances physically together, and if they do mix evenly throughout, we call those mixtures homogeneous, and if they are randomly mixed throughout, then we call those mixtures heterogeneous. So this is the basic classification scheme on how matter is organized. Okay, so I hope that this helps paint a picture, and I also want to stress the importance that solutions, all solutions, are considered homogeneous mixtures, and in that category we have alloys. And just to wrap it up, keep in mind that there are many popular alloys. I mentioned steel, but you have other alloys like brass, which is copper and zinc. You got bronze, sterling silver, white gold. There are many different types of alloys that are out there, okay? But when those solids are mixed together, they are blended together uniformly, and the fact that they're made that way makes them homogeneous. Okay? And that will wrap up our tutorial here on the classification of matter.